Hello everyone, welcome back to my channel. So in this video we are going to learn about electric field due to circular disk. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get the video notifications from my channel. So circular disk, I'm considering a circular disk here, right? Okay, so this is the circular disk where you have the charge density which is distributed over the entire circle. So sheet of charge we are taking, so that is why the sheet charge density is rho s, which is coulomb per meter square. Okay, so from this I am drawing the coordinate system onto this circular disk. Okay, so this is z, y and x. Okay, so on the circular disk I am taking a small amount of sheet charge. Okay, I am considering a small amount of sheet charge. So in the opposite direction also you will have the same sheet charge here, right? So that this is angle phi and this is radius rho, and this is the point of interest 0, 0, h, so that this line or this distance from the origin is going to be h, and I'm joining this also. Okay, and this will be r bar, as we have seen in the previous case also. This will be r bar, right? So this is the consideration which you have taken off. Okay, so same as my previous videos also, same manner we will do the analysis. So I am taking this point as some m. Okay, so I am considering the triangle PMO. O is origin here, so I am considering the same triangle PMO. Okay, so this is the triangle, so this is your r bar, right? And this is rho and this is h. Okay, so this is m, p and o. So mp bar is equal to, right, so mo bar plus op bar, mo bar plus op bar. So from m to o, rho is decreasing, so as we have seen in the previous cases also, so minus rho a rho cap plus h into ah cap, this is r bar. So then what is r? Root of minus rho whole square plus h square. So if you understand my previous videos, this is very easy, rho square plus h square r. So r cube is rho square plus h square whole to the power of 3 by 2. Okay, so these are the considerations which you have to take. Then what will be E bar? So I'll write here. So then what will be E bar? E bar is integral s rho s ds by 4 pi epsilon naught r square into ar cap. So integral s rho s ds into r bar by 4 pi epsilon naught into r cube. Okay, where ar cap is equal to r bar by r. So if you substitute here, r bar by r square into r is r cube, right? So E bar is equal to integral s rho s in ds into what is r bar? So r bar is this one, minus rho a rho cap plus h into ah cap plus h into ah cap divided by 4 pi epsilon naught into what is r? R cube is this, rho square plus h square whole to the power of 3 by 2. Okay, so same as the previous case, whatever the E bar in the direction of AH, So whatever the E bar here, so same E bar will be existing in the opposite direction, so that the net E bar net in arrow cap direction, in the direction of arrow, is going to be 0. Okay, so everywhere if you see here also there will be an opposite direction. Okay, so again net is equal to 0. Again net electric field intensity is equal to 0. So that means the electric field intensity due to this arrow cap is going to be 0. So electric field intensity is due to H direction, Z direction only, is AZ here. I'm sorry, AZ here, not AH. I'm really sorry. So AZ here. So net electric field is in the Z direction only. Right? So E bar is equal to integral S rho S ds into H AZ cap divided by 4 pi epsilon naught into rho square plus H square whole to the power of 3 by 2. Okay, so what is ds then? So in the direction of AZ, we need in the direction of AZ. So in the direction of AZ means ds is equal to rho d rho d phi. Rho d rho d phi. So I have explained you this in my first classes. Okay, so basic classes only I have explained you this, how to take the value of the ds value, differential surface. Okay, so rho d rho d phi. So E bar is equal to integral S rho S into rho d rho d phi. In the place of ds I am substituting with rho d rho d phi into H AZ cap divided by 4 pi epsilon naught into rho square plus H square whole to the power of 3 by 2. Okay, so phi we know that limits are from 0 to 2 pi, and what are the limits for rho here? 0 to a, because a radius, maximum radius here is a, so rho extends from origin to the a value. So here the radius is going to be a only, so this maximum value is a and the minimum value here is 0. Okay, so radius exists from 0 to a. Okay, so that E bar now becomes integral rho is equal to 0 to a integral phi is equal to 0 to 2 pi, phi is equal to 0 to 2 pi rho s into rho d phi H into AZ cap divided by 4 pi epsilon naught into rho square plus H square whole to the power of 3 by 2. Okay, so understood up to here? So let me take one more slide. I'll start doing from this step. Okay, so we have got E bar is equal to integral phi is equal to 0 to 2 pi integral rho is equal to 0 to a rho s into rho d phi into H AZ cap divided by 4 pi epsilon naught into rho square plus H square whole to the power of 3 by 2. So integration is with respect to rho and phi. So this rho s, 4 pi epsilon naught and H along with AZ cap, the unit vector is also a constant, you can write outside the integration. So rho s by 4 pi epsilon naught into H AZ cap. Okay, integral phi is equal to 0 to 2 pi d phi into integral rho is equal to 0 to a rho d rho by rho square plus H square whole to the power of 3 by 2. So this integration is 2 pi. Okay, because d phi is phi, and if you substitute the limits it will be 2 pi. So rho s into H by 4 pi epsilon naught into 2 pi AZ cap into rho is equal to 0 to a rho d rho by rho square plus H square whole to the power of 3 by 2. So 2 2's are, and let rho square plus H square is equal to t, then 2 rho d rho is equal to dt. So rho d rho is equal to dt by 2, and limits also changes. When rho is equal to 0, t is equal to H square. when rho is equal to A, then T is equal to A square plus H square. So then it becomes rho s into H by 2 epsilon naught Az cap integral. So I'm converting this integral in rho to integral in T. So when rho is equal to 0, what is T value? H square. So H square, right? And A, when rho is equal to A, it is A square plus H square. So rho d rho is dt divided by 2, and rho square plus H square is T, so this becomes T power 3 by 2. So this 2 is a constant, you can write outside. So rho s into H by 4 epsilon naught, right, integral H square to A square plus H square T power minus 3 by 2 dt. Okay, so then E bar is equal to rho s into H by 4 epsilon naught into T power minus 1 by 2 divided by minus 1 by 2. Limits are from H square to A square plus H square. Okay, so this becomes minus 2 rho s H by 4 epsilon naught. This minus 1 by 2, if you send it to numerator, so it becomes minus 2 into, so first upper limit, A square plus H square whole to the power of minus 1 by 2 minus H square whole to the power of minus 1 by 2. Okay, so this is the value which is obtained after substituting the limits, right? So it is 2 ones are 2 twos are here, so minus rho s into H divided by 2 epsilon naught into 1 by A square plus H square, A square plus H square whole to the power of 1 by 2 minus 1 by H. So Az cap is there. Az cap. Okay, then what will be this value? So if you take LCM, minus rho s into H divided by 2 epsilon naught into, so if you take the LCM, H minus A square plus H square whole to the power of 1 by 2 divided by H into A square plus H square whole to the power of 1 by 2. So this H and H gets cancelled, right? So then what will be the value? Minus rho s by 2 epsilon naught into H by A square plus H square whole to the power of 1 by 2, so H by 1, so this will be minus 1, so this and this gets cancelled off, so you'll get minus 1 Az cap. If you take minus common here, so the final expression E bar is rho s by 2 epsilon naught, so I am taking this minus inside, so it will be 1 minus H by A square plus H square whole to the power of 1 by 2 Az cap. Okay, so this is the electric field intensity formula of circular disc. Okay, rho s is called the surface charge density. Okay, surface charge density here, and A is the radius of circular disc. Okay, A is the radius of the circular disc. Okay, so if you have this, and this is the formula for electric field intensity due to circular disc. Okay.